This conference will now be recorded.
Okay, so far in the last class, actually, we have covered client-server architecture and then capacity planning, and what about the hardware sizing and others, right? So I'll just review the topics now, and then I'll move forward. Okay, what is the client-server architecture? Client-server architecture is a distributed application framework dividing the tasks between the servers and clients, which is either reside in the same system or communicate through a computer network or the internet. Right? The server components provide a function or services to any one or many clients, which initiate the request for such services. Services are classified by the services. Servers are classified by the services which we provide. Example, we have so many servers like it's a web server which serves the web pages, and the file server which serves computer files or reports or invoices or whatever it may be, and so on. Clients and servers exchange the messages in a request and response messaging pattern. The client sends the request and the server returns a response. To communicate, the computer must have a common language and they must follow the rules so that both the client and server know what to expect and what to return. The language and rules of the communications are defined in the communication protocols. All right. Then client computers provide an interface to allow a computer user to request a service of the server and display the results the server returns. Servers wait for the request and arrive for arriving from the clients and then respond to them. Okay. And capacity planning. Say for example, in the client and server, say for example, when you are sending a request to the server, that time the server can process the request and it will return the response to the client. If the response is in ideal time, which is in expected time, that's not a problem. Then we are good that time. But when we are processing the means when the server is processing a response, if there is a delay or if is there any timeout expired, then we have to consider that there is a performance issue occurred. So that is where the performance engineering concept will come. First of all, to move on to this concept, first of all, we have to just go for capacity planning. I'll just open that slide and then I'll just check. It's a capacity planning. Capacity planning strategy involves the process used to determine the resource manufacturers need to meet the demand for their product and services. The level of capacity directly relates to the amount of output in the form of goods and services manufacturers can produce to satisfy customer demand. Say for example, as a stakeholder, business stakeholder, I can come up with some business requirement so that the solution architect has to design and then has to identify all the aspects and then they have to give the one thing to the business stakeholder, like say for example, we need this hardware and we need this operating system, we need these softwares and others. Say for example, if the business architect expects some application at a time, say for example, if at a time 1,000 users are requesting information from the server, that time the business users is expecting the 1,000 users at a time. If the 1,000 users are connecting to the servers and then if they are requesting, then we should not think about only the 1,000. We should think about that future also, and then based on that we have to plan it and then we have to just tell them like we need these softwares, we need this hardware capacity, and then we need these many people, means manpower to achieve this task and others. So this is where the capacity planning will hello.
Suresh sir, yeah, just one confusion. Last class didn't we cover this, or was it also, is it a continuation from the last class?
No,
Looks like
that's what only. No, I'm telling you like for the last, it's a recap, that's it.
okay,
Because it's
got
already 1 week over, right? That's what only. I'm just
okay.
covering only the highlights. That's
Sure, okay, got it.
okay. So this is the capacity plan, which will do that. Okay. Then this is the continuation for that. that class. Okay, because we have so far we have covered the capacity planning, then we have covered that what is the client server architecture and others. So now I'm coming to that .NET classes. Okay.
Got it.
Yeah. In the .NET, actually, one of the main concept is the CLR. But before we move on to the CLR, we should know about the .NET framework little bit, because the CLR will come into the .NET framework, which is a main concept in the .NET framework. What is the .NET framework? .NET framework is a software development platform developed by the Microsoft for building and running the Windows or mobile or web applications. The .NET framework consists of developer tools, programming languages, and libraries to build desktop and web applications. Alright, the .NET framework is developed by the Microsoft, which is useful for running the Windows, mobile, and web applications. Okay, .NET framework can be used to create both form-based and web-based also. Say for example, it's a web-based meaning like it's ICICI Bank website. So Windows meaning like maybe Windows desktop applications only we have, right? So both form-based and then web-based also we can create, and even web services also we can create by using the .NET framework. .NET framework supports various programming languages, such as like in the .NET framework we have around 60 languages. Those are like it's a Visual Basic, Visual C#, F#, and others. So whoever is comfortable, so I'm comfortable, say for example, if you are comfortable with the C#, you can write the logic, you can write your pages in the C#. So if I'm comfortable in F#, then I can use the F# and then I can develop the own code in my F#. So like that. So developers can choose and select the language to develop as per the requirement and as per their knowledge. Okay. Then the .NET framework means that is released. The first version is 1.0, which is released in the year 2002, and the current version is .NET 4.8, which is released in the 2019. Now I'll move on to common language runtime. The common language runtime is a heart of the .NET framework, and it is a runtime environment for the .NET framework. So .NET framework, the common language runtime is a heart for the .NET framework. The CLR manages the, means it's a CLR meaning it's a common language runtime, which will manage the life cycle and execute the .NET applications code. It also provides the services to make the developer processor easy. So CLI is the main heart for the .NET framework. In the common language runtime, it is manages the execution of the programs written in any languages that uses the .NET framework. As I told you earlier, like it's a, I can write the code in C#, VB.NET or F# and so on. So it will take whatever the code written in other languages, it will take that and it will process that. So the common language is the, again and repeat, the common language runtime manages the execution of the programs written in any one of the languages, like it's a C#, VB.NET and F#. Programmers write the code into any language, including VB, C# or F#, that the compiler will compile their programs into an intermediate form of the code called it CLI, which is a common language integration. So whatever I have written the code, which will be compiled into an intermediate form, which is like it's a CLI in a portable execution form. It's a PE that can be managed and used by the CLR, and then the CLR converts into a machine language code so that it will be executed by the processor. I'll repeat, whatever we write the code in the C# or F# or maybe any language, CLR will take that code and it will convert that code into intermediate language, then it will be executed by the processor. The information about the environment and programming language and versions and what class libraries will be used for this code are stored in the form of metadata. So in the CLR, there is a keyword called it's a metadata, which will contain all the versions and what are the programming language we have taken, what about the environment, and everything will be stored in the metadata. Then the functions of CLR we'll see now. The functions of CLR is convert the CLR will convert the code into CLI. I have told you above, like it's a common intermediate language, which is a cross-platform toolchain used for developing, building, and running and publishing the .NET applications. So, which will convert the code into CLI. See, whatever we have written the code in any one of the 60 languages, like it's a C#, F#, or VB.NET, the CLR will convert the code into CLI. It's a common intermediate language. Then the next function is like it's an exception handling. The CLR will the next function is it's like it's try by using the try catch blocks. It will handle the exceptions also. Then the CLR is like it's a type safety, which is like a type safe code access only for the memory locations. Type safety meaning like it's a type safe code accesses only the memory locations which is authorized to the access. Say for example, I have public, private, and others also will be there, right? Say for example, based on that type safety, it will access that code and it will read the code. And the memory management also, the memory management by using the garbage collector, which I'll cover in the future sessions. And the security is also more with the CLR. And by using the CLR, the performance also will be improved. And then the next is like it's a language independency. Like I told you, like we can write the code in different languages, like I stated, like C#, VB.NET, F#, etc. And it is a platform independency, means its languages will be converted into standard language, which is a common to all. It's like a Microsoft intermediate language. Say for example, whatever the code I have written in C# or VB.NET or F#, CLR will take that code and it will convert that one to intermediate language, which is like Microsoft intermediate language, which is MSIL will call. Then the MSIL will be converted into a corresponding target machine language by using the just-in-time compiler. So we'll call this one as a purely platform independent. Any questions so far?
No, six.
Then the benefits of CLR we'll see. The benefits of CLR is it's a class loader, meaning like which is used to load all the classes at a runtime. Then converting the MSIL to native code. By using the just-in-time compiler, we will convert the machine language. It's like a Microsoft intermediate language into a native code. Then code manager, which is like it manages the code at the runtime. Then the benefits is like again garbage collector. It manages the memory, collect all unused objects and deallocate them to reduce the memory. Thread support also it will have, which supports the multi-threading of our applications. This is the benefits of CLR. And exception handling also there, as I told you, like it's by using the, sorry, any question?
Yeah, Suresh, you spoke about the platform independence, right?
Correct.
So as of now, we know only Java as platform independent code, right? So how is .NET also platform independent?
No, platform independent, why I'm telling you is, say for example, in the .NET, we have around 60 languages, as I told you, like it's a C#, F#, and like it's a VC++, right? In any language, you can write the code, but CLR will take care of it, and then it will convert into Microsoft Intermediate Language. So
Okay,
wherever you
it
want
means to say within the framework. Within the
yes,
framework,
correct.
whatever is
Within
the
the framework.
language,
Yes,
it is
correct,
platform.
correct.
But it is nothing to do with whether it's running on Linux or Windows, nothing like that,
No.
right?
It's not. No. Within
Got
the
it.
framework itself. That's
Yeah.
what only have covered the .NET framework initially.
Okay.
Any other? Any other questions?
No.
Okay. Then CLR, so far we have seen that. Then the benefits also we have seen, like, then I'll come up with the common type system. The common type system is a part of CLR, which will describe the data types that can be used by managed code. I'll tell you in detail like what is managed code and then unmanaged code in the next session, in the next slides. Okay. Though the CTS describes the data types that can be used by managed code. The CTS, meaning like it's a common type system, defines how these types are declared and used and managed in the runtime. It facilitates the cross-language integration, type safety, and high-performance code execution. Say, for example, in the C#, I have the integer data type. Say, for example, int data type. And in VB.NET, when I'm declaring the variable, I have to declare that one as an integer, like it's a I capital integer. But both will be converted into a, like it's a system.int32 we have, right? It's like it will come from the framework. So it will convert like that. The common type system is like, say for example, you can write the int in C#. I'll write the integer in VB.NET. But at the time of conversion, the .NET framework will convert that integers or whatever it may be into system given data type. For example, for the integer system.int32 it will convert. Say for example, if it is a big int, it will convert to system.int64. If it is a small int, system.int16 it will convert. If it is a normal int, then it will convert to that one to system.int32. And for the strings, it will convert to system.string. This is a common type system, which is a main concept in CLR again. Then we have another concept called CTS, which is common language specification, which is like it's a common language specification. The common language specification is a subset of CTS. I have already told you, like it's a CTS is a common type system. So common language is a subset of common type system. It defines the set of rules and restrictions that every language must follow, which runs under the .NET framework. The languages which follow these set of rules are said to be CLS compliant. Okay, the CLS is also a subset of CTS, and the CTS is the one of the main component in the CLR. So these three main concepts are very important in the CLR and which is in the .NET framework. Okay, any questions so far?
Can you please explain the CLS and CLR
CLR
again?
what? Yeah.
Yeah.
CLR meaning like it's a common language runtime. Say for example, in the .NET framework, when you are creating the object, okay, say in the memory, say for example, int I you are creating it in the .NET. Say when you are writing the code, okay, that time the framework has to allocate some memory to the variable, right? You got it? Or
Yeah.
you created one class, say for example class sample. Okay, that time when you are creating the object a specific class, that time the CLR means that the framework has to allocate the memory to that. And you got it?
Yeah.
Okay, that time the memory allocation has to happen by some of the concept, right? Some of the tool, some of the concept. That concept is called as CLR, which is like it's a common language runtime, which will take care of allocating the memory and calling the garbage collector also. Okay, garbage collector is one of the concept in the CLR, which is like a common language runtime. What garbage collector will do? It will try to deallocate the memory for the allocated objects. You know, I guess you already know about that garbage collector, but I'll explain in the further. Okay, that is the CLR. CLR is useful for everything, like it's a memory management kind of thing. It's a CLR, like it's allocating the memory and then calling the garbage collector and then taking care of the security and then try to take care of about that this one exception handlings also. So every concept will come under the CLR itself. Okay, and again I'll come to that common type systems and then common language specifications. I'll repeat. Common type systems, as I told you, we have around 60 languages in the .NET, right? It's a C sharp. Say I'm writing the code in C sharp. Maybe as per the client requirement, VB.NET the client will ask, right? So that time in the VB.NET, when you are creating the integer or something, you will declare the variable using the integer, integer with complete word. Okay. But in C sharp, we'll create int int itself only. Okay, for integer int. Okay, for string completely we'll use as string. For float we'll use as float. Okay, like that. But the common language runtime it takes care of all the languages, right? Then it will convert that code into a Microsoft intermediate language. Say you have written the code in F sharp, I have written the code in C sharp. That time when you are writing the code in C sharp, int you have given, in VB.NET I have given the integer. Then how the system will convert that into a system language? That time the CTS, meaning like which is like it's a subset of common language runtime. That time the CLR will convert that one to, if it is an integer, system means like it's a system.int32, it will convert for the integer variable. For the string variable, it will convert that one to system.string, like that. If it is a small int, then system.int16 it will convert. If it is a big int, system.int64 it will convert. So that is a system defined, framework defined data types. You got it now?
Yeah. So you spoke about the 16 different languages within .NET Framework, right? Can you name a few?
Yeah,
Because
that's
mostly what
what
I've seen, yeah, what we have heard mostly is the C sharp, right? What
Yeah,
other
C sharp,
languages?
yeah, C sharp and F sharp is there. Okay, yeah. VB.NET is there, VC++ is there, ASP.NET is there. Okay, if you want, I can just type it and then give it to you later. End of the session in
Sure. Yeah,
the this
maybe
one.
some of the well-known ones. Yeah, maybe the
Yeah,
well-known
yeah.
ones.
Because ideally in the market, I'm telling you that one also. In the market, only will use ASP.NET, C#.NET, which is more important because most of the 75% people will use the C#.NET, okay, and ASP.NET, okay. Either
Okay.
ASP.NET is common, but for the code behind, say ASP.NET is a designer kind of thing, right? Which will have the controls, like it's a UI on that is, okay.
It's a framework.
Yeah, it's a framework kind of thing, which is like it's a UI. Say for if the button controls, checkbox, radio buttons, text boxes, okay, and others will be there in the ASP.NET. Okay, so when you browse somewhere .aspx, you will see in the URL, right? So for that ASP.NET, the extension is the ASPX pages. In the older version, you could have seen that .asp pages. Now in the .NET we have ASPX pages. Okay, the ASPX is a common, but further code behind, meaning like for the database creations and to perform some actions, we should have some language, like which is a code behind language that might be C sharp, F sharp, or VB.NET or VC++.NET, whatever it may be. But ideally in the market currently we are using C sharp or VB.NET as a code behind, and for the designing we are using ASP.NET. Any confusion or any questions?
No, ASPX is for the latest C#, right?
No, it's not a C#. ASP.NET is also one of the languages in the .NET framework.
No,
Which is
dot,
I told you like
dot. Yeah, I spoke about the .ASPX pages, right? That is
correct.
for the latest C# version, right?
Latest C# version you are telling?
No, is that for C#? ASPX pages?
No. That's what only. ASP.NET is a web application extension, which is like it's a, say for example, when you are developing a web application, right? That time you
I
will
got it.
create a
ASP.NET Framework, right?
yes,
No, what I
correct.
was saying is the .ASPX pages we will see
Is
for C#
extension.
only. Yeah, that
No.
extension is for C# coding, right? Or is it
Uh,
for general one?
it's a general one. General one.
Okay.
For the C#, no extension will be there. Okay. No, ASP.X extension will not be there. For the web applications, extension will be there, which is like it's a ASPX. Okay. And
Yeah.
in the for the design for the UI, in the next session, I'll give you one example with the ASPX and with the C#, so that you will have some better idea on that.
Yeah.
Okay.
And what about the .svc files? They are what extension are they? .svc.
SPC is for
.svc.
ID.
That also will
No. ID.
.svc.
.svc.
Yeah, I've seen
You
such
are asking
also.
the ASP.NET.
Yeah. For ASP.NET applications,
It's a
we notice.
.svc file contains a small. See, the .svc file contains a small snippet of the code that will define the
Okay.
Windows Communication Foundation service only. This is
Okay. So
okay. Yeah.
I think where I have noticed the .svc is maybe in while drilling down in AppDynamics, I think, right?
Yeah. Got it.
So when
But
do
it will
what?
when you are using the WCF applications, maybe that SVC file will come. The extension will come.
Is that?
Your voice is breaking,
Sure.
Isha.
Okay.
Any other questions?
Yeah, I got it.
Okay,
No.
okay. Then in the next session, what I will do is I'll just prepare one small application with the ASP.NET and then C#. Then I'll run through it and then I'll show you. I'll deploy it and then show you so that you will have an idea what is ASPX and what is the C#.
Yeah,
All
got
right. Okay. Then as I told you, like a CLR. So the CLR is completed now. Then I'll come to the next concept, which is a Git compilers. Okay. In the .NET, Git compiler is a part of common language runtime in the .NET, which is responsible for managing the execution of the .NET programs, regardless of any .NET programming language. Okay, a language specific compiler means which is a Git compiler converts the source code to intermediate language. This intermediate language will then be converted into machine code. Okay, say for example that the common language runtime is converting the code into MSAL format, as I told you above, right? That MSAL format will not be understandable to that machine, to the operating system. Then something has to be happen to understandable for the system. That time the Git compiler will comes into the picture. Then it will take that MSAL code and then it will convert into the machine code. So what Git compiler will do, whatever the common language runtime is converted that the .NET code to MSIL, which the Git compiler will take it and then it will convert that one to the machine code. Okay. Then the machine code is specific to a computer environment that the Git compiler runs on. Okay. Say for example, I am running in one system. Say I written some code in C# or F# or any other language. That time when I'm running when I build the application, when I run the .NET application, the CLR will comes into the picture. Then it will take that code and it will convert that code into Microsoft Intermediate Language, which is a .NET Framework language. Then the just-in compiler will fire, and that will take that MSIL code, means that MSIL code, and convert that one to machine language to process the request. Okay. Then the Git compiler is also required to speed up the code execution and provide the support for multiple platforms also. Okay. Git compiler converts the, as I told you, Git compiler converts the Microsoft Intermediate Language or common language, common intermediate language into a machine code. This is done before the MSIL or CLR can be executed. Then I'll repeat, the MSIL is converted into a machine code on a requirement basis. That is, Git compiler compiles the MSIL or CIL as required rather than whole of it. Means at a time it will not convert that one. It will not convert that one to machine language. Whether first it will take that one MSIL code or common. Like I told you, like it's a common intermediate language. It will take it and then part by part it will execute, and then it will just convert that one to system language. Means like it's a machine language. So we'll have three types of Git compilers. Actually, we have those are present, normal Git, and econo Git. So three types of Git compilers we have. Those are preset and normal Git and econo Git. What preset will do is, the source code whatever we have written is compiled into a machine code at a time in a single compilation cycle. Say for example, I have large application. When I'm building that application, then that preset will convert that code into a single compilation by using the preset compiler. This compilation process is performed at application deployment time. Okay, at the time of application deployment time, preset will comes into the picture, and it will be that source code will be compiled into a machine code at a single time, at a time in a single compilation cycle. That is a preset. Then the normal Git, I'm coming into that. Normal Git is like it's the source code methods are required at runtime are compiled into a machine code at the first time. Say for example, I have written some code in the .NET. Okay, so main class I have written. Inside that class, I'm calling some sub function. That sub function, I am not directly call that one, right? That time when it will call, when I'm calling that function, that time itself only the sub function will be executed. Otherwise, unnecessarily to execute that one. So because of that itself only will split the code into a single parts. Say that time that normal Git when comes into the picture, and then whatever. Hello Deepa, can you hear me? Deepa, can you hear me? Hello Deepa.
This
Yeah,
conference
Okay.
will now be recorded.
Yeah,
Previous.
I have. You can see my screen, right? I can Git. I have
Yeah.
normal Git.
We were in the previous. Yeah, we were in the previous
Preset.
screen, I think. Yeah.
Okay, this one preset compiler, right? Yeah, this one only. Okay. The preset. What is the Git compiler? What Git compiler will do? So when we are building the .NET application, the CLR will convert the .NET application code into a MSA language, which is a Microsoft Intermediate language. Okay. Then the Git compiler will come in, and then it will convert that code into a machine language. Right? So that the three types of Git compilers are there, which is like preset, normal Git, and econo Git. What is preset will do? The preset will do all the preset will take care of all the source code and compile into a machine code at the same time in a single compilation cycle. Okay, this compilation process is performed at the application deployment time itself only. Preset will take that code and then it will convert that one into a machine code at a single compilation cycle time at the deployment stage. So that is the preset responsibility. Okay. Then Next, the econoset will come. Next slide, which is like it's an econoset. The econoset, the source code and methods that are required at the runtime are compiled into a machine code the first time by using the normal Git compiler. After that, they are stored in a caching technique and used whenever they are called again. Say, for example, in the C#, I have one class and I have one big function. Say, for example, add function I have. So inside that add, I have some function like it's a subtract. So anything you can take it. Say when I call that add function, only that add will call. Until I call that sub method, means until the add method is executing, the sub method which I am calling in the add method will not be fired. You agree, right?
Yeah.
Okay, that time whatever I have called, whenever I have called that add method, that time that sub method also, the subtract method also will be called. So that subtract method will be called at the runtime. So that normal JIT will takes care of that runtime methods and it will be executed that time first time. Then after that, whenever in the subsequent request, if we are calling the same function again and again, it will be taken from the cache because the normal JIT compiles at the initial stage and then it will keep that functions in the memory in the caching technique. Then it will be used further until the session is alive. If we disconnect or if we log out and then if we come back and then if we are performing the same action, again the same thing will happen. Got it? That is the normal JIT. Okay. Then I'm coming to that next one, which is like it's a econojet. Econojet is like it's the source code methods are required at the runtime or compiled into a machine code by the econojet compiler. After these methods are not required anymore, then they will be removed. That will be removed. Say for example, I have called one function. That time the main function add method is called. Then inside that add method, the sub method I'm calling it, that method will be executed and that time, the first time, and it will be keep in the caching, in the memory. Whenever I'm calling that again, that normal JIT will be fired and it will be taken from the caching itself, cache itself only. What but it will not delete that memory from in the econojet. In the normal JIT, sorry, I'm confused. In the normal JIT, the econojet also will do the same thing, but whenever that memory is not required, whenever that use is done, say for example, the subtraction method I'm not using anymore, that time econojet will fire, it will remove that memory. Okay, so far we have seen three JITs: preJIT, normal JIT, and econojet. Any questions on these three?
At this point of time, how will it be known that one particular function will no longer be used
That will come.
for
That
the
will yeah. That will be comes in that my next sessions actually. I'll show it to you. Okay, that will be covered in the next session. This is the outline. Okay. Then the advantages of JIT compiler. So far I have covered the JIT compilers. The advantages of JIT compilers I'll tell you now. The JIT compiler requires the less memory usage as only the methods that are required at the runtime are compiled into a machine code by the JIT compiler. Okay, whatever it is useful for the runtime. Say I'm running one application, so that time, say for example, I'm requesting some information from the server. That time, what and all the required information I require, what and all the method has to be executed to perform that action that will be run. And other than that, other things will not be run by using the JIT compiler. So JIT compiler will take care of that one to not to execute all the code. Got it? And then the page faults are reduced by using the JIT compilers as the methods are required together are most probably in the same memory page. Say for example, that memory usage and other things I'll just cover in the garbage collection. and the virtual memory also I'll cover in the next slides. Okay. Then the code optimization techniques also will be there in the Git Compiler. Okay. Now I'm coming to the fundamentals of the memory. Okay. Then the fundamentals of memory meaning like that is for first of all, before we move on to garbage collector, we should know about that virtual memory. Then we'll go for the stack and heap. Then we'll go for the garbage collector. Okay. The fundamentals of memory. Before we move on to memory management, we should know few concepts about the memory management. Okay. So in the .NET or any other application, each process has its own separate virtual address space that you already know. All the processes on the same computer share the same physical memory and the base file if there is a one. Okay, by default, if I want to say by default in the 32-bit computers, each process has a 2 GB user mode virtual address space. So for example, in the 32-bit operating systems are there, no? So for as an application developer, if we work on any, if you work only with the virtual address space and then never manipulate the physical memory directly, we should not means we will not manipulate any virtual memory, because whatever we are writing it, say for example, until we are say you are declaring one variable int I. Say for example, until you are committing that one code change, it will not be committed to that original folder or original file. Until you are saving that one, it will be in the physical memory, means in the virtual memory itself only, and that cannot be manipulated by the anyone. So in the virtual memory, we'll have the three parts actually, three states it will have it. One is a free state, reserved state, and a committed state. Which is like it's a free state meaning like the block of memory will be useful for the allocation of the memory, which is like say for example, when I'm creating the integer variable, that time the free it will go to that free memory itself only. So it will find out that free memory and then it will try to insert that variable in the virtual memory. So that time when it is inserting in the virtual memory, then it will be reserved for that integer itself only. Say for example, I have written one variable string equal to Suresh, I have written it. So until I have saved that one code or compiled, then that will be reserved for my processor itself only. So that will be reserved for me actually. So nobody can access that one. And when I click on save button, then the block of memory is assigned to a physical storage. Got it right? There will be a three states. One is free and one more is reserved and other is committed. Free is like it will be free to allocate the memory. Reserved is when I'm assigning the variable which is not committed, which I have not saved it as of now, which is a reserved one. And when I click on save button, then it will be a committed one, and that time the virtual memory will be released and that the variable will be assigned to the physical storage. Okay, then the virtual address space can be fragmented also. Say for example, for each and every process there will be a separate virtual memory will be allocated. Say for example, I have virtual memory of 2 GB. I have created so many. Say for example, when you are copying something, it will be copied to the clipboard, right? So the clipboard meaning like it will be a virtual memory itself only. Say you have copied a huge amount of data. That time when you are pasting somewhere, sometimes you may face few issues also. Say for example, clipboard is deleted, or maybe you do not have much memory to allocate the means to save this in the virtual memory like that, which is meaning you do not have the free virtual memory to save the clipboard content of data. Say for example, I have the space in the virtual memory 2 GB, but it will be a blockage kind of thing. Somewhere 10 MB, somewhere 10 MB, and somewhere 10 MB. But when I'm copying something, which is like it's a 2 GB data at a time, when I click on copy button, sometimes you will be facing like cannot copy, or maybe there is no enough space errors also you will get it, right? Because whenever you are copying the data, all the virtual, say for example, you are copying the 2 GB of data, that time the 2 GB of data should be at one place itself only. It should not be in the blocks wise. It should not be in the different places. Say if you are having that memory at one place, then the item will be copied, then you will be able to successfully copy from one place to another place, or else it will give the memory leakage error also. So that time you will have something, maybe you will get the run out of memory or enough virtual address space, some error you will be getting it. So this is the virtual memory concept. Okay, any questions so far? Deepa, you can hear me, right? Hello, Deepa, are you there? Deepa, are you there?
This conference will now be recorded.
Now the next concept is stack and heap. Okay, before we move on to the garbage collector, we should understand about the stack and heap in the C#. Okay, so when we are declaring a variable in the .NET application or wherever, when you are declaring a variable, it allocates some memory in the RAM. Okay, the memory which allocates the RAM has the three things, like it's a name of the variable and then data type of the variable and value of the variable, right? So when you are declaring anything, the name of the variable and the data type we have to give and the value of the variable we have to give, right? So the time when you are, there are two types of memory allocations for the variable which we have created in any one of the applications. Okay, those memories are like it's a stack memory and heap memory. Let us understand the stack and heap memory with the examples. Okay, in order to understand the stack and heap, I'll give one example now. Say for example, here I have a screenshot of int x equal to 101, int y equal to 102, and the statement 3 some class equal to class 1 I have declared it, right? So in the statement 1, int x equal to 101, when the first statement, that statement 1 is executed, one second, Deepak. Yeah, sorry, Deepa. You can hear me, right? When we
Yeah.
are executing the int x equal to 101, okay, the compiler allocates some memory in the stack. Okay, the stack memory is responsible for keeping track of running memory needed for our application. So when the statement is executing the, say you can check in the right hand side in the screenshot, like x equal to 101 is assigned, right? Like that. So when the statement is executing the second line, the stack will allocate the memory at the top of the first stack. Okay, so the stack method is like it's a last in first out concept. Say whatever we have inserted the most recent one, it should be deleted first. It's like it's a last in first out concept. Say for example, I have inserted initially int x, then after that int y I have inserted, then after that int z I have inserted. So when the memory is releasing, z has to be released first, then the y will be released next, then the x, the most initially whatever we have assigned the variable, no, then that one will be released last. So it is like a last and first out concept. Okay, then when the third statement is executing, we have created an object, like it's some class is a class, CLS1 is an object, then we are creating a new keyword there, right? That is when we are creating the object for a particular class, which is a reference to a particular class. Say when we are creating the reference types, the memory will be created at the heap itself only, not at the stack. But the reference variable will be created at the stack, but the actual memory will be allocated at the heap. You understand the concept, right? The reference, whatever it is, there will be created at the stack. But main memory will be used from the heap itself only for the referenced objects. For the primitive data types only, the stack memory will be useful. Primitive data types like boolean, char, integer, byte, float, double. These are the primitive data types. Okay. Then the objects, class, structures, and other things are non-primitive data types. So for this, when we are creating the reference types, the memory will be allocated from the heap, but that reference will be to stack itself only. So when we are coming down from the execution path, say for example in the method, when the third statement is executed, the compiler will comes to that next statement, like it's a closed curly braces, right? So that time the object memory will be deallocated for integer x and integer y, because it is a stack memory, which is like when the statement is completed, the .NET, the compiler will be released that memory, because which will be no longer will be useful. So the static variable means like it's the primitive data types will be useful, will be live until it is come out of that block. But still some class that reference is there, right? That will not be erased, because which is a heap actually. So that will not be erased, because which is in the heap memory. Say in this screenshot, when we are coming out of this block, exit the memory, which is I highlighted in the red, right? So when it is coming to this this statement, it will be removed the X memory and then Y memory from the stack, but still the heap memory still be there, because which is a heap memory, so which will not be removed from the heap. Because of that itself only, the garbage collector will comes into the picture to remove the heap memory only, to deallocate the heap memory. Any questions so far?
So the reference object is also removed from the stack?
No, your voice is breaking, please. Again, can you repeat? Can you repeat?
Yeah, there was a reference object, right?
Correct. Correct.
In stack that also got removed. The reference object in stack
Reference will
is
be
the
there. Yeah.
oh, it's
Yeah.
still not
Reference
removed.
will be. Yes. Yes.
How about
Reference will be removed. Reference will be removed.
so
I got your.
how about now?
You got it. Can you hear me? Deepa, can you hear me?
So yeah. So that this is I mean there can be a yeah I'm able to hear.
Okay. The whatever it is there in the stack, when we are come out of the function, right? It will be removed. But the memory, the size, say for example, for the particular class, you have assigned the size in the heap memory, which is a 2 MB, right? The 2 MB memory will be allocated to the heap, which will not be cleared when the method is come out of the function, because which is a heap memory, because the .NET wouldn't know whether that object is still be used or not. Okay, so which we have to remove, we have to check whether that object is needed or not. We have to check, and then we have to take an action to call the garbage collector, or maybe a destructor method. Like, so based on that itself, the garbage collector will come, and then it will just arrange the memory. It will clean up the memory, which I'm going to cover in the next slide. Okay. So, as we know, in this, yeah, as we know, as I have explained you already, the primitive data types such as integer, double, boolean, etc., they just hold a single value. Okay. On the other hand, the reference data types or object data types are complex. An object data type or a reference data type can have a reference to other objects as well as the other primitive data types also, which is the reference will be there in the stack, but the main memory will be allocated at the heap. Okay. So when an object is stored into a heap, no longer use that the object does not have any references pointing, then the object is eligible for the garbage collector. I'll repeat. In the heap memory, you have some object. So that time, if the object is no longer be used in our application, that time that object is eligible for the garbage collector to remove it. At some point of time, the garbage collector will deallocate the memory, but even nobody knows when the garbage collector will fire. So garbage collector will call internally in a particular time frame, and then it will just check unused objects, and then it will try to release the memory. Okay. So far I have covered this one, CLR, PLS, PTS, Git compilers, virtual space, and then stack and heap. Any questions as of now?
No, sir.
You are good, right? Okay. Then the garbage collector, which is like, it's a very huge concept. Actually, it will take in the garbage. I'll give the outlines, then I'll cover in the next section what is the garbage collector. Okay. The garbage collector is a which will take the memory management also, which is like it will work on the heap memory, which is like it will just check whatever the objects are created, or whatever the reference objects are created, whatever the classes for the particular class. If we allocate any memory, garbage collector will check whether that memory is useful further, or it is still in the usage or not. Then it will try to release the memory. Okay. Garbage collector will have the 3 generations, which is like a generation 0, generation 1, and then generation 2. The generation 0, most recently, it's like it's a normal life cycle will be there. No, when, say for example, when I'm creating string str equal to Suresh, when I'm creating it. So these kind of simple objects will be there in the generation 0. Okay. When the for the particular generation 0 also, there will be a space limit. Can you hear me, Deepa, again? You said like my voice is breaking. Can you reply to message again when if you can hear me?